right, gentlemen, welcome in. Just come in, make yourself comfortable. I'm just taking attendance, so that's, you know, this stuff is like intricate and detailed. There's a lot of moving parts, so it's easy to kind of go less, but it's okay. I'm trying to take you guys, log you guys' names without saying your names, and I always want to, say your name. See, I was about to say that. Right here. And then I think BCD. And then cool. Okay. Oh, one more. Okay. Cool. Okay. Let's let them in. No real announcements. So this is what, the end of week 5, right? We had exam 1 last week. I think we said several times. Hang on. We said several times that for exam 2, you can pretty much anticipate the same thing. I just want to incorporate an oral component. More than likely, I'll make it worth 20% of your grade. I do need to sit down and go ahead and make the scheduling block so people can start signing up. It'll be okay. We'll have time. So all I'm going to do today is just kind of continue working through the homework. If you have a question or you'd like me to work on a specific question, just get my attention. Right now, you can unmute yourself or type in the chat or raise your hand or something like that. And the best practice is to make use of the Ask My Instructor. It'll send me a screenshot of your question with your numbers. That way I'll load it and we'll make our way through yours. So yeah, so I'm just here for questions. We're going to go ahead and continue with section 1.4. I'm not sure that that's what I did with you all. That was just a continuation of, that's pretty much where we should be. Again, exam 1 was 1.1 through 1.3. So that's why like this week I'm focusing on 1.4. I've already done the lectures for 1.4, 1.5, and 1.6. So those are available on my YouTube channel. Be sure to like, share, and subscribe. Shameless plug. But yeah, they're already there. So there's an updated playlist with updated live lectures. You'll find it there. And then also, I mean, honestly, the lectures, all the things I want to say for the entire semester are already there as well. Because it's the same information from the spring. I'm just making an updated version. We have here it is. Okay. Yeah, so I'm just doing it fresh, just like that. Okay, so continuing where I left off, we're just going to keep working on section 1.4. I might move into 1.5 this week as well. So with this question, this is question number 15 from this section. It comes from section 1.4. Let me make sure my people at home can see. Okay. It comes from section 1.4, question 49. And we're asked to sketch the graph of this piecewise function. Okay. So I'm going to do this one by hand first without looking at the graph to show you the backstory on how to graph a piecewise function. And then I'll come back and like maybe I can show you some shortcuts or some other ways to graph this. So first I'm going to do it by hand. So the first thing I want to do, I want to get a copy. I'm going to suppress my audio just so I can focus. Hopefully you guys can hear me. Let me make sure. Ali Oxenfree, that looks good. Ali Oxenfree. Okay, I'm not going to worry about it. So first I'm going to graph this by hand just to give you the backstory. So let me get a copy of this. Let's see. Let's go from here. We'll take all of this. Okay. I want to share. I don't want to airdrop this. Come on. Come on. You know you want to. There you go, right there. There we go. Sending, cool, and it looks like it's been added. And I'm going to bring it up here, add photo library. This one, add, okay. Oh, okay. So it's doing that thing. Give me just a moment. This one, come on. This one, okay. Much better. Okay, and let's crop. Okay, I'm about to get the student in just a moment. Ugh. Let's see if this works. Okay, that's better. Cool. Okay. Let them in, and let's hop over to the tablet. I think we got to do like this for the people at home, which is everybody. Okay. All right. So let's look at the backstory on this. We're going to do this one by hand first. So all a piecewise function is, when you see something like this, when piecewise is basically you just graph it like normal. Like these are really multiple graphs on one Cartesian plane, right? So it's like you have the first line, like if you had y equals absolute value of x, you just graph it like normal, but then there are some restrictions, like you only show a certain window of it. And so the domain, those x values tells you what window to show. Okay, so let me see. I'm gonna do some graph paper. Let's do like this, right? So say we're on graph paper. Let me see, x goes from -5 to 1, and then off to the right. Okay, okay. So let's do a xy plane. So say like this is the origin. Let's make this like 1, 2, 3, 4, 5. We probably don't need to go that far. Then to the left, here I'm gonna just copy and paste. Nope. Copy, paste. And so like this is our x-axis, right? Positive x is going off in this direction. Our y, let me see, I can paste again. And then what I'm gonna do is rotate by 90. And I'm gonna have to remove a few, but that's okay. So I'll delete that. And then let's undo. Let's copy, paste, and I'll remove what I've done. What's a little bit extra. Like I think a lot of this, yeah, a lot of this is extra because we're not going to be down that low. Okay. And let's undo. I'm just making like some graph paper. Okay. So we have our positive x going off to the right, positive y is going up. Oh, we have two in the waiting room. Let's see, I think I got both of these students already. Okay, there's one. H, cool, okay. We can let him in. All right, so now let's do this. Let's graph the first one. Let's do this one in blue. All right. Style and the fill, it's that same color. All right. Let's do that one in blue, and we'll do the second one. We can do green. We'll do, let's just copy and paste. And we'll do the second one in green. Okay. Okay. So the first one is if we had like y equals absolute value of x, right? So I think that's one of our basic functions. We're not doing any transformations on it. We're not moving it up or down or anything like that. So it's really just a v. You can make a table. You can choose several values of x, find the corresponding y. But you really just graph it like normal, but then we have some restrictions. So if you graph it like normal, we'll get the following. For instance, when x is 0, absolute value of 0 is 0. When x is 1, and let me label my axes. So you got like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 2, 3, 4, 5, 6. These are negatives. And then this is the origin, 1, 2, and these are negatives, right? So then absolute value of x, for instance, absolute value of 1, when x is 1, we choose 1. Oops. Absolute value of 2 is 2. So on and so on, right? Okay, let's just go ahead and talk about the well. Let me finish the image. Absolute value of -1 when x is -1, the corresponding y is 1. Absolute value of -2 is 2. Absolute value of -3 is 3. Let me do it like this. Paper. For some reason, I graph better when it's these dots. It's less. I think it's less going on. 3 is here. This one. 4 is here. And I think we kind of need to go one more, which would be here. All right. And then if we connected it with a smooth curve, let me see. It's essentially going to be a straight edge like that, like this. Let me undo that. Let's try that again. Okay, that'll work. And then actually, so the graph essentially looks like this, right? Where it's basically a V and it goes like this, right? But we have a restriction, right? So this is the graph of absolute value of x. This is a basic function. It's essentially just a V with the vertex at the origin. But this piecewise function says that the graph is restricted, the domain is restricted for this component from -5 to 1, right? So anything left of -5 we need to get rid of. So we only come up to this point here. And let me use my partial eraser like this. So we can get rid of, I think I got it. We can get rid of that. And then it's restricted from -5 up until 1. So we need to get rid of, use my partial again. We need to get rid of like this stuff. And then let's do the whole thing. Just that, honestly, that, and that. Okay. And then now it says from -5 to 1, because on the left hand side there's a bar, whereas like x can be equal to -5, we're going to use a closed circle on that part. But then for that 1, because there's no bar right here, because x is strictly less than 1, so it's not equal to, so we're going to use an open circle there. Let me do like this. Let's go here. Nope. Come on. Here, instead of that, let's do it this way. And then let's go style. I want to fill with this one. And the stroke, make it a little bit thicker. Let's do it. And then let's see if I can make that. There we go. Just being a little bit. Okay. Anyway, right? So that's the gist of it. Let me do this real quick. It shouldn't take that long. Now that's a little off, and that's irking me. But I don't think I can get it any more precise, so I'm not going to worry about it. Let me copy this. Copy, paste. And this will go essentially here. And then fill. Again, it needs to be a closed-in circle, right? Okay, so that's the blue graph, right? So it's just absolute value of x, but we only show the part where x is greater than or equal to -5, but strictly less than 1. So again, it's greater than or equal to, that's why we have a filled-in circle up here on the left. And then, but since it's strictly less than 1, that's why that circle is open. Let me let the student in, and then we'll get back to it. What is this? Okay. Cool. Good one. Okay, so that's the blue one. Let's go ahead and do the green. So then for the green one, that one is the square root of x, right? But it says that it's restricted to x is greater than or equal to 1, right? So normally, square root of x, the domain would be greater than or equal to 0. So like square root of 0 is 0. Square root of 1 is 1. I think it actually fills it in because they have the same value. So what happens, let's graph some perfect squares. So I think the 1 is kind of already plotted. 2 is not, let's do the square root of 4. The square root of 4 is 2, right? So then when x is 4, corresponding y is 2. The next one will be 9. It goes a little bit off our chart. See that that's 6, 7, 7, 8, 9 will be like 7, 8, 9 is here. And then 3 is like here, right? And so what would happen, because that they kind of they share that same point where the other one was open, this one is actually going to be, it's just going to get filled in by the second graph. So then when you connect the points with a smooth curve, you get an image like this. And square root, the graph of square root is just the top half of a sideways parabola. So you get a graph like this, right? So that's the long and short. That's the skinny on graphing a piecewise function. A piecewise function, again, all it is, you just graph it. It's just multiple graphs on the same Cartesian plane. You graph it like normal, and then erase the parts that you don't need. So for the absolute value, essentially all I was doing was a V going through the necessary points. I erased anything for the blue graph. I erased anything that was to the right of 1 and to the left of 5 in this case. And I kept everything in between. The 5 got a closed circle or filled in circle because it can be equal to the 5. The 1 got an open circle because the blue part cannot be equal to 1. It gets really, really close to x equals 1, but it doesn't actually reach it. But then that point actually gets filled in. It just happened to get filled in by the second graph because the square root of 1 is 1, and it can be equal to 1, so that's why we filled it in the green graph, right? So doing it by hand is like this. Before I put it on Pearson, and hopefully Pearson is still working. Sometimes when I'm way too long, it acts up. Let's say you have a graphing calculator. Let me see if I can get my virtual graphing calculator working. I'm hesitant to move away from that screen, but I kind of need to. We're going to open up this guy. I agree. Choose the file. Browse. Ooh, I got to dig back into my files to find this thing. I think it's this one. Which one? It's not that one. It's not that one. What is the one that I was using? I had one that I was using. Let me see. I think there might be. Let me check here. This one. Yeah, this. Can I copy this? That's fine. It's working now. It doesn't matter. Reload and refresh. Okay. So what you're seeing now, this is like a virtual calculator. I found it some years ago. I was looking for I want to say maybe 10 years. I was looking for a long time for something like this. It never dawned on me to just make it myself. Tag on it. Hang on, I got another student. Let me get my credit. Hopefully it's still working. Who is this? Yeah, okay, got him. We're gonna hop back to the calculator and show it here and let him in. Okay. So I had to go through this whole thing so I don't show all you all's information on my stream. Yeah, so this is a site called Chemtechnet. Like I guess it's some students from another university like decided to make an emulator, probably some computer scientists. And this thing actually works. I've been using this for some time, like a few years now. But once I found it, I tried it out, it worked. It's free. It takes a little bit of effort to get it working. This is just something I stumbled across. And I had to download some files like ROMs and stuff like that. But eventually I got it to work. So like I said, I've been using it for a while, for some years. Anyway, so say you're working on a calculator like this. Oh, let me think about it. There is a way to do it. Let me see. I don't even remember how to do that. Let me think about it. I might have to look it up. Like there is a way to do it here. I think I'm going to, just so I'm not eating up so much time. Let me think about it. Let me think. I had to do a quick search. Let me search here so I'm not eating up my power. I'm going to do a quick search on how to graph a piecewise, but you can graph it on a Texas Instrument on this. So let me see. I'm going to pull up a quick example. Graph. Nope. Graph a piecewise piece. Calculator on, let me see, TI, what is this, 84, 83? TI 83, okay. Let me just pull up a quick example. Let's see this one. Blah, 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 blah. Okay. Thick dot, that's fine. I'll set that in a moment. Enter the function, blah, 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 right here. Okay, I think I got what I need. Okay, so now let's give this hours a go. So if I go to math, I think if I go over to number 1, you see absolute value. So I'm gonna hit enter. We want to graph the absolute value of x, right? Okay, some other things that I need. So this first part, I need to put it in parentheses. I'm glad I looked it up because I totally would have forgotten about that. Then the second part, now the restriction here is that x goes from -5. If I go to test, where's test? Test is above the math on the left. Less than or equal to is number 6. So -5, I think this will work. Let me just try it out. And then if I go back to test, and strictly less than is number 5. And what do we say? 1, right? Okay, absolute value of x as x goes from -5 to 1. And then the second one is a square root, which is here. Square root of x. Oh, parentheses again, so we need to do it like this. Parentheses. And then the restriction on x is that x is, if I go back to test, x is greater than or equal to, which is number 4. Greater than or equal to number 1. And then I also need to kind of set my, I need to go to this thing here. I think we need to do dot. Let me see what it says. It says, I think we're okay. Dot, did I say dot? I saw something else. Maybe that's a different. Okay, I think we just need to put it in dot mode. Okay. Connected sequential. Okay. Okay, so let me put this in dot, and then I also need to get the student. Let's hit graph and see what happens. Oh no. Later. Okay, so I know what's going on there. Let's go back to this y equal. It's this less than, this -5, this compound inequality. We might have to, give me just a moment. X is greater than, okay. So the change that we got to do right here, it's overloading it, so we got to go like this. We close out, we do x is greater than or equal, -5 is less than or equal to x, and then I'm going to come back and say x is what, strictly less than 1? So you have to just break it into multiple parts. Test, which is number 5, x is strictly less than 1. So I think for a compound inequality, you kind of got to do it like that. Let's try this graph again. Boom. There's the first one and the second one. Oh, I don't know if you guys can see it right there. All right. Let me get the student real quick. That takes a little bit of effort. I just wanted you to see that it's possible, right? This is the C. Cool, got them. All right, and then like this and like this. So again, I just wanted it to be a showcase so you can see that it's possible. I don't think there are any questions popping up in the chat or anything. We got, time is almost up. I just wanted to kind of do that so you can see that it's possible, right? So again, this was just a website I came across. I don't expect you to use this, but like if you're on a graphing calculator, I just wanted you to see that it was possible. Let me make sure I'm still showing for my stream. Okay, right? Another site, I guess since we're doing demos today, let's pull up another one. So another site that you all can use that is free. It is called Geogebra. Actually, I think it has it. Do I have it as an app? Geogebra. It's like geography and algebra, something like that. Geogebra. Actually, I think I might have the app. Let me see if my app works. But yeah, if you go to geogebra.com, that's actually one of them. Let me see, Geogebra. There it is. Oh, do I need to download it? Okay, that's fine. But yeah, so some free online graphing tools for graphing stuff like this. One of them is Geogebra, which I literally just downloaded it just now. I had it from before, but you know, we're gonna see if we can get it to work. I don't really. I honestly had to think about Geogebra. Let me try something real quick. So like for instance, if I'm trying to do this piecewise, so if I said something like y equals, oh yeah, okay. Let's try y. I forget the nomenclature. Y equals. Let me see. Maybe this will do it. No. Let me just do y equals. What if I do like this? Absolute value of x. Okay, so there's a graph. So now we want to try to impose the restrictions, right? So this is restricted from, what do we have? -5. Let me see if I do -5. If I say less than or equal to, okay, that's fine. X, and then, but then that's strictly less than 1. Okay, what if I hit enter? Do I need to change? I know I need to change some things. I'm not really sure how though. Let's see. So we got the graph, y equals absolute value of x. Oops, well, we had it, x, right? But we need to try to get those restrictions in there. And again, if we just search Google like we did before, let me see. Let's try from -5. Come on. We're almost out. I'm about to let you guys go soon. We got like a solid 10 minutes. Less than or equal to x. Let me see what happens if I hit enter. I gotta look that up. If settings delete. Yeah, I'm just trying not to look it up for the sake of time. Let me think about one other thing. Okay, let's do this. X is greater than or equal to 5. What if I put that in parentheses? What happens? It's not letting me do it. Comma. Okay, I'd have to look that up to get it to work all the way. Yeah, what does that do? Does that do anything? No. Yeah, I'd have to look it up. I guess since I did the other one and, you know, we don't have that much time, let me just do a quick search. Graph piecewise function Geogebra. There it is. So Geogebra, again, it's just free online graphing software. Piecewise functions. Geogebra. Okay, I think it's this one. There it is. We need a colon. Okay. Okay. They got theirs just like that. Okay, let's see what did they type for that. It is possible. The worksheet will help with this. So you need to input it in this format. X is less than some number, first equation, second equation. Okay, if you can change the pound, first equation, second equation, you can also change the pound numbers. You can change the number. You can also change the numbers in the 3 equations. Okay. So that seems like the code right there. Let me see if I can copy this. Okay, I want to copy from there to here, right? I'm going to copy this. I'm going to hop back over to Geogebra. And I'm going to just type it like right here. Paste. And with a lot of these kind of like software, once you find the code, you can copy and paste it and edit. A lot of times you can. Let me paste. No, it's not gonna paste. Okay, I think it did something like if. Let me try here. Paste. No. Let's try one more time. Can I copy? No. What did I do? Go back. Here it is. copy and paste. No? Okay. Let me see, I'm gonna just type it. If x is less than something, first equation, second equation. Okay, and I think that's what this thing was saying. If, okay, so let's go like this. So the first one, we said -5 less than or equal to x, which is strictly less than 1. Then we want to do, and I thought, like, I was a little confused because, like, I thought we already had that and we couldn't get it to work. Let's go here. Oh, maybe we just needed to type it. One other thing is that, like, okay, I did use a square bracket instead of a parenthesis, so that could be the change. And then let's see if we can go ahead and get this other one in here. Let's just do another. So we're gonna let that be the first one, and then we're gonna repeat that. So I think we did, we said if, and we did square brackets. So then, what's the second one? Square root. So I'm gonna hit \sqrt for square root. That usually does it. Square root of, oh, sorry, not square root. If x is what, greater than 1? X is greater than 1. Can I do square root? Let's do backslash. Is it backslash square root? I saw it popping up. Square root, yeah, parentheses. There it is, okay. Maybe we didn't need the backslash. Sorry, I got all this like chatter. Square root of x, right? Boom. Oh, x. Why are you doing that? X. There it is. Cool. We actually got it. Right? So it was an adventure, and it was only like that because, like, it was a learning curve, right? It's the first time that we've used it. Like, I know it's the first time that I've used it in a long time, but I know it's there and it's possible, right? So you see the digital version where we produced it digitally. And I mean, it's like, honestly, whatever graph you want to create, you can make it in these things. Another one is called Desmos. I just was doing a showcase for you guys to see the stuff. Let me check the chat real quick. Oh yeah, it's okay. Yeah, I haven't been like stressing. I mean, I've been taking attendance, but you know, I hadn't been making too big a deal about it. Okay, so that was enough of that. Let's hop back over here. So we saw 3 different ways of graphing this. We saw how to do it by hand. We saw how to do it in a Texas Instrument calculator, and we saw how to do it on this free site called Geogebra. So let's go ahead and submit this. We don't need this. We can let that stay. Let's hop back here. Let's go here and like this. Okay. Continue. So let's see if we can see these graphs. So the one that we got, it looks like the only one that's close to what we got is A. Yeah, I'm not really sure why it looks like that, but it's A. All right, we're gonna check. Let's see the time. And again, the reason it took so long is because we were trying to figure it out. And then going forward, now that we know the tools, the more you use it, the faster it goes. So it just takes like that time initially. What's the domain? So if we look at the graph, can I blow this up? Let me see, like this, it's one of these. It's okay. What does this one do? Yeah, that's what I wanted. Yeah. Okay. The domain, right? So remember the first one, it said that x was greater than or equal to -5. So there was nothing to the left of that. But then it's all connected. And because these two connect right here, and then the second equation went all the way, is an arrow going to the right. So that means that if we're talking about the domain, the far left is going to be -5, and the far right, because there are no holes or gaps or anything, the far right is going to be positive infinity, right? So the domain for this is going to go from -5 to infinity. There are no holes or gaps or anything of that nature. Okay, that was a little bit of a drag. It took us a good amount of time, but you know, let's get a few more in there. What's the range? The very bottom to the very top, right? So the range is the very bottom to the very top. So if we look at the graph again, how far down does the graph go? The lowest y value is 0. The highest y value, again, because of this arrow, it looks like it might be 5, but this arrow, it continues the pattern. If you continue the pattern, it'll reach that 5 and go beyond it, right? It'll keep going. So the lowest y value is 0 and the highest is infinity. You do kind of have to use your imagination, and you have to be aware that to continue the pattern. So 0 to infinity, and 0 gets a square bracket because we actually touch 0. It's included. Okay, let's try to get at least one more in. We'll go a little bit faster, a lot faster now. Okay, average rate of change for this function as x goes from 0 to 8. Let me take some notes real quick. Find the average rate of change in a function. For the sake of time, I'm just going to do it here. So rate of change, average rate of change is nothing but the slope. So it's basically saying find the slope between these 2 points, right? So slope is what? Y2 minus y1. So the second y value is what? 24 minus 0. So we know the top is 24. All right, we're just finding the slope. And then the bottom is going to be 8 minus 0. So the bottom is 8. So then 24 divided by 8 is what? 3. So all I did was y2 minus y1 over x2 minus x1. So I just found the slope, and that seemed like it was okay. Let's hang out for like 5 more minutes, and I'll let you go. Again, for our purposes, for our discussion, again, whenever we see average rate of change, it's just the slope. So given this function, it's saying find the slope between these 2 points, right? So our y2, for instance, when x is 3, 9 times 3 is what? 27 minus 4 is 23. So the first part on top is what? 23. We want to say minus. Now when we plug in x equals to -1, -1 squared is a positive 1. So then 1 times 3 is 3. 3 minus 4 ultimately is -1. So 1 minus -1 becomes, 23 minus -1 becomes +1. And I'm just doing this I'm doing it this way for the sake of time. So the top ends up becoming 24. On bottom, we got to say x2 minus x1. So we're going to say 3 minus -1. That minus -1 becomes +1. So then that becomes a 4, right? And then so 24 divided by 4 is 6. Okay, cool. I know that was a mouthful. I was just doing that because we only have like 3 minutes left on the clock now. I'm literally watching the clock, and I don't want to keep you past 9:45. That's like 3 minutes away. Oh, difference quotient. Do I have the time? All right, this will be the last one. I need to write this one out though. So the difference quotient. Let's do this one. This is a good one that we need to talk about. Come on. Okay. Oh, I don't know. My technology might be working in your favor because it is totally. We got a solid, still like 3 minutes. So I'm gonna do. This will be the last one though. I want to do this one. Let's go back to paper. I'm just going to take some notes. Okay. So this is question number 18, right? This is question number 18. This comes from section 1.4, question 57. I'm going to say find the difference quotient, okay, of the form. Let me say of the form. I'm just taking some notes. We got this f of x minus f of a. That's f of a over x minus a. Okay, where x is not equal to a. Okay, and then we're given this f of x equals, we got 5x squared plus x, where a is equal to 3. Okay, let's hop over to the tablet like this. There it is. Okay. So these are the notes I just took. Find the difference quotient of this form given this function, right? So we already have f of x. Let's go ahead and find f of a. F of a, in this case, this is going to be what? F of 3, because a is equal to 3. So that's going to be 5x squared plus x. Again, what goes in for the x's in this case are the 3's, right? I'm watching the clock. I'm about to get you guys out of here. Hopefully you can have a good weekend. Give me just a moment. So then 9 times 5 is 45 plus 3. Looks like that's 48. Okay. So we have our f of x already. We found f of a. Okay, so let's just put all these pieces together. So then f of x is going to be 5x squared plus x. We're going to say minus f of a, which is 48, over x minus 3. That's not a 3, right? Can we factor the top? What's 5 times 48? 5 times 50. What's 5 times 50? 250? 250 minus 10, 250. So it should be what, 240? 240 sounds good. Are there two numbers that multiply to give us 240 and add to give us 1? Okay, let me go through this list real quick. So if we have a negative 240, I just want to see if I can factor this. We're looking for two numbers that multiply to give us a negative 240 and add to give us 1. Let's see. So if we go through the list, we got 1 and 240. Now 240 was 5 times 48. 48 is what, 6 times 8? So 240, 6 and 8. 2 times 2 times 2 times 2 times 3 times 5, right? Let me see. 10, 6, 60 times 4, 240. Okay. So now if we just quickly go through the list, we got 2. If we use that first 2, 8 times 5 is 40. That's what, 120? We got a 3. We got what, 16 times 5 is 50 plus 30 is 80, right? But that's not the 2. Can we do 4? We got 4. We got 20 times 3 is 60 left over. We can do a 5. What is it? 16 times 3 is 30 and 24 is 54. Let's keep going. We did 5. I'm going to continue over here. We can do 6. 8 times 5 is 40. Okay, 6. We can't do 7. We can do 8 though. 6 times 5 is 30. We can't do 9. We can do 10. 8 times 3 is 24. We're almost there. 10, 11, 12. We can do 12. Because we do the 4 and the 3. For instance, when I'm doing 12, I know that I've already used that 4 and that 3. So 4 times 5, we got 20 left over. All right, almost there. 12, 13, 14, 15. We can do 15. And we got 16 left over. And those are the two numbers that we're looking for, 15 and 16, all right, because they add up to 1. So let's see. We're almost there. I know the time. Let me see the time. Yeah, let's keep going. We're almost there. So then now what we're going to do is rewrite that middle term. So this x in the center, I just did this because this is a good learning moment to do some factoring, or to see if we can do some factoring. We're going to rewrite that green x using the 15 and the 16. I'm going to intentionally put the 15 next to the 5 and the 16 next to the 48 because they have common factors. So then what happens is we have this 5x squared. That 1x we're going to rewrite as negative 15x plus 16x, and then minus 48. I'm watching the clock. We're also racing against time. Okay. So now if we group the first two, what can we factor out of the first two? This is I call this the AC method of factoring. We're using several techniques here. If we factor out 5x, we're going to be left with x minus 3. That's what we were looking for. This guy right here. Style. That was the one that I was looking for ultimately. So what can we factor out of the second two? The second two, they both have, it looks like a 16. And it should be another x minus 3, right? That was a good omen when we had that x minus 3, because that's what I was anticipating the whole time, right? 16 times 3 is 30 plus 18. Yeah. So then we have a common binomial factor we need to address. The two terms on top both have this blue thing, all right? And what's left over? We got 5x plus 16 divided by this guy. Boom, boom. And we're going to say like this. And, oh, that's not a 16. I'm just trying to write fast as I'm racing against the clock. There's one. We also need to acknowledge that x cannot be 3. Okay, let's go back. Yeah. So the final thing we got was 5x plus 16. Let's hop over to Pearson really quickly and see how do we do so I can get you guys out of here. We might not have to do that acknowledgement. We got 5x plus 16. Okay. That's what I got. Let's go with it. Awesome sauce. All right, that was fun. With a full minute officially left on the clock. Okay. Okay, that was an adventure. Okay. My recommendation, definitely link up with the tutors and definitely link up with students that feel like they're getting it. Hopefully you guys are making your way through the lab. The lab component is run by Dr. Lamar. If there aren't any burning questions, guys, have a great weekend. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.